In this screencast, I'm going to go over how I evaluate and review the descriptive stats and the inferential stats in a published journal article. Sometimes statistics seem scary and we just kind of skip over them while we're reading a journal article, perhaps, but there's actually an easy rule of thumb that we can use to just see for ourselves what we think about the conclusions that the author makes. And I'm going to do this with this article that I just happened to be reading. It's called The Effects of Task Repetition on Learners' Attention Orientation in L2 Oral Production. I was reading this article because I also study L2 oral production. And the idea here is what happens in the performance, the accuracy, the fluency, the complexity, and the variety of lexical items that a learner uses if they have repeated a task and we'll see later that they also thought about or reflected on their performance between the first time and the second performance. So moving down to the methodology section, we can see the procedures. There were two experimental groups and two comparison groups. Let's look at the experimental groups. The key here is they performed the task A. Then they had a stimulated recall activity where they heard parts of their performance and thought about it, and then they repeated that task. So, and that was either task A to task A or task B to task B. And let's just scroll up a little bit and see what that task was. So the procedure is that they had to tell a story based on a 6-frame cartoon. One was called Surprise, one was called The Chase. And the author assures us that the two cartoons have similar structures, both 6 frames with a punchline. But the topic was different. So the author is saying that the two tasks were the same type, but they were different tasks. So scrolling down again, so here, this group did surprise, surprise, and the other one did the other task and repeated that same story. But in the comparison group, they did one of the picture prompts, the 6-frame cartoons, and then they thought about how they performed during it, but then they were given the other cartoon. So the question is, does thinking about your performance only help if you're doing the exact same story, the exact same task, or might thinking about your performance transfer to another task? So the comparison did A then B or B then A, whereas the experimental group got to do A and then A again or B and then B again. And the research looked at the syntactic complexity, clauses per AS unit. And a clause is a noun phrase, verb phrase, and an AS unit is like a sentence. So there has to be at least one clause per sentence, but you can make a compound sentence or a complex sentence when you're speaking, which would be more complex. The research also looked at accuracy, the percentage of error-free AS units, fluency, pruned words per minute. Pruned means how many words were said after deleting any hesitations or repetitions or partial words. And they did a measure of lexical variety, which calculates different words used in the speech. So I've scrolled down here to Table 3, the descriptive statistics. And I think it's helpful. I just went ahead and highlighted the means for the first and the second for the experimental group and comparison group. But for this, we're just going to really focus on the experimental group, because what the question is, does this activity of thinking about your performance and then repeating the performance helps? That would be the question this comparison would do. So let's just look at in the first telling of the story, the learners, if you averaged all of the scores together, the mean was 65.39 words per minute. And the second time, it was 70.25. Now, that is a little improvement in performance, but the difference is, I'm going to just round here and say it's about 5 words per minute. Now let's look at the variation within the scores. We know that there are lots of individual differences. All the learners did not perform exactly the same. Some spoke a little faster, some spoke a little quicker, some had more words, some had more repetitions, some had more corrections in their speech. So we're just going to look at the standard deviation. How much did those scores vary? Well, the standard deviation was over 16 on the first time. So just looking at the difference here, the proposed improvement was 5, but just the variation in differences was 16. So just looking at this descriptive stats, I would say there is not going to be a difference, that this author cannot say that this experimental activity improved the fluency on the retelling. And to double check, let's go down to this picture. So here is the bar says that the top of the bar gives the mean, and then these error bars give the standard deviation, how much the scores varied. So some of the students scored here, some here, here. And then on the second telling, the mean was up here, which is a little bit higher, but some students scored here. So is that a difference? No, because there's a lot of overlap. The fact that this is just a little bit, starts a little bit lower, and this is a little tiny bit higher, that could just be random variation. So let's see what the author said about that. So the t-test showed that the differences in fluency were not statistically significant. So yeah, that makes sense. Let's look for the next one. The next one is clauses per AS unit. We said that they have to be at least 1. And we see that it's just over 1.18. And on the second telling of that same story, it changed to 1.2, which is not much of a difference at all. So it would be just 0.02. That's probably not going to be a statistically significant difference. So especially considering that the variation between the learners is 0.13. Again, much higher. Let's scroll down and see what the picture looks like. Again, here's the means, and the standard deviations show that they're really overlapping. You can see that for whatever reason, the comparison group, there was more variation between the learners inside the group than there was on the first and second retelling. But of course, they're telling a different story. So we would expect that there is no difference, and the inferential stats says that the differences were not statistically significant. The variation between the students within the groups much bigger than any change or improvement that we might look to. Okay, let's look at the accuracy measure. We have a mean of 0.4, and then on the retelling it went to 0.52, 52% versus 40%. So that's a 12% improvement. And the standard deviation is about 11% or 21%. So the question is that going to be a statistically significant improvement? Let's scroll down and see the picture just to compare. So this is the accuracy. You can see that there was variation in accuracy. Not all students were equally accurate. Some were just above 5. Some were all the way down at 30% of the AS units being error-free. But on the second telling of the exact same story, some students got all the way up to, 70+% accurate in their AS units. So this could be a statistically significant difference, but there is some overlap. So let's look at what the stats showed. The author says that the difference in accuracy scores in the experimental group was statistically significant. So given that that was the result from the inferential stats, the t-test, we can probably surmise that some students did really well after going through this process of telling the story, thinking about it, and then telling that exact same story. They were able to improve their performance, the accuracy in their performance enough that made that statistically significant. Now, this is just a rule of thumb. Other things come into play. For instance, the number of students. If there were about 28 students, so this ended up being statistically significant, even though there was still a wide range. If it had been a lot of students, it's more likely to, if you have 1,000 participants, it's way more likely that a very little difference, even this one, could be statistically significant. The question is that meaningful? But I just wanted to point out that more goes into it than just the difference in the means. Okay, so let's look at the last one, which is the trickiest one here. In the variety of words that the learners used, the first telling, it was 0.86, and the second telling, it was 4.97. So the difference is only 11. And the variety, the individual differences, the standard deviation was 0.7. So what does that tell you? Well, that tells you that, no, there shouldn't be a statistical significant difference. So let's look down to what the author says. The author says that lexical variety in the experimental group was statistically significant. And that really made me curious that with only 28 participants, that little bit of a difference shouldn't have been statistically significant. In order to check it, I would have to get all the raw scores and run it myself, which I didn't have access to. I only have means and standard deviations. But based on that, it just didn't seem very likely. So I emailed the author, and the author confirmed to me that actually there was an error, that this should be 4.68 versus 8.6. So the difference was actually closer to 3. So then it started to be a little more plausible that there was a difference. So I just wanted to talk you through what I think about when I look at descriptive stats and evaluating the inferential stats. And we can just review what we learned. Students' fluency doesn't change that much based from telling the same story. Their complexity didn't change hardly at all. They stuck with mainly one clause sentences in the story. And what did change for these learners when they got to retell the exact same story after reflecting on their performance is that they got to improve their accuracy, and they also could vary their the words that they used in the second time. Maybe they thought of some other things to say. So I hope this was helpful. feel free to post questions and ask